let's take a look at the second part of number 17, where we have to figure out what the distance is. So in the last video, we looked at displacement of the particle. And in displacement, the integral takes care of, computing the integral from 0 to 10 takes care of this business here, where between 2 and 6, the area is a negative signed area because the function dips below the x-axis between 2 and 6. So for figuring out displacement, where a particle actually ends up or where something actually lands, the position, the integration from 0 to 10 completely does that for us. But we have to add another step if we're trying to figure out the specific distance that a particle has traveled. So thinking more about what the odometer on a car would read after the particle has been moving from time 0 to time 10. And the only place that that's going to require us to do something different is between this interval 2 to 6 where the area was negative. What we want to do is something that, for at least that little block, makes the area positive. So we want the area to be up here instead. And not that difficult to do, but it does require integrating it in pieces. So we're going to integrate the function from 0 to 2, then from 2 to 6, and then from 6 to 10. And when we integrate the function from 2 to 6, we are going to negate that area. So we're going to change it from being a negative area to a negative negative, or a positive area. So here's what that's going to look like. We're going to compute distance traveled by the particle, which means that we're going to integrate from 0 to 2 like we always do. Then we're going to integrate from 2 to 6. Remember, that's the negative area, the area below the x-axis. And then we'll integrate from 6 up to 10. When we integrate the area from 2 to 6, remember that's where it's below the x-axis here, we're going to subtract that area. So we're going to subtract a negative area, which in the end will make it positive. We'll be adding ultimately. All right, so let's do that. So we're going to integrate the function from 0 to 10, or sorry, from 0 to 2. So 36 minus 24t plus 3t squared dt minus the integral from 2 to 6 of 36 minus 24t plus 3t squared dt plus the integral from 6 up to 10 of 36 minus 24t plus 3t squared dt. And we figured out from the last time that when we integrate from 0 to 2 or 2 to 6 or any of that, my integrated function looks like this: 36t minus 12t squared plus t cubed. And we're going to evaluate that 3 times. We're going to evaluate it from 0 to 2. We're going to evaluate it from 2 to 6. And we're going to evaluate it from 6 to 10. The only thing we're going to be careful about is that we're going to subtract whatever we get when we evaluate it from 2 to 6. We'll add whatever we evaluate it from 6 to 10. All right, so this is just a bit of computation stuff. So 36 times 2 minus 12 times 2 squared plus 2 cubed. When I plug in 0, I'm just going to get 0. So I know I'm subtracting 0 here. That'll be my first round of evaluating. Then I'm going to subtract 36 times 6 minus 12 times 6 squared plus 6 cubed minus, right, I still have to plug in the 2, minus 36 2 times 2 minus 12 times 2 squared plus 2 cubed. Put that in parentheses. And then to that I'm going to add 36 times 10 minus 12 times 10 squared plus 10 cubed. There's the upper limit. Now I'm plugging in the lower limit, 6. So I have to subtract this one. So subtract 36 times 6 minus 12 times 6 squared plus 6 cubed. Zoom out so I can see that big, long, crazy looking evaluation. Ooh, I have to zoom out even more. That is gigantus. I would probably do this in parts in my calculator. So evaluate this piece, evaluate this, and then subtract them. Evaluate this, and then subtract them. And then put them together. When you do all of that calculating, you should end up with 224 meters traveled for your distance.